Hello and welcome to my course update to Modern C++. In this video I'm going to give you some idea of what you can expect from the course. First of all, what is Modern C++? C++ was inherited from C. It was originally concerned with arrays, pointers and inheritance and things like that, and it was first called C with classes. Obviously some later features were added, such as templates, exceptions and the standard template library. But for many people, C++ really is C with a few extra bits stuck onto it. In 2011, a new version came out, which is quite a different language, in fact so different that it's often called Modern C++. It was a substantial revision to C++. Lots of new features were added, some of them borrowed from other languages, and there are many improvements to existing features. As Bjarne Stroustrup said at the time, it feels like a new language. So what are the advantages of Modern C++? Well, first of all, it's safer. For all the C features which are dangerous, things like explicit pointers, built-in arrays, there are safer alternatives. The compiler can generate loops for you, so you no longer have to worry about running off the end of an array. And there's no need for programmers to manage memory themselves. Modern C++ is more expressive. You can write local functions which make containers and algorithm functions from the standard library work better together. And there are better abstractions which reduce the amount of so-called boilerplate code that you have to write. Boilerplate means code that serves no useful purpose. It's just there to satisfy the bureaucratic needs of the compiler. And finally, it's more efficient. More work can be done at compile time, which means there's less work for your program to do at runtime, so it'll run more quickly. And also, you can avoid making copies of transient or temporary data. The benefits of this are that there's less low-level code to write and test, so the development process will be quicker. The code will be clearer and more expressive, so it's easier to understand and easier to maintain. The code is more likely to be correct and efficient, which means there'll be fewer defect reports and fewer performance issues. And you can avoid many situations which cause undefined behavior, so there'll be fewer crashes and less debugging needed. We're going to start the course by reviewing the developments in C++ in the late 90s, early 2000s. So that's the Annotated Reference Manual, the 1998 and the 03 standards. So if you're a bit rusty or not completely familiar with these, this will get you up to speed. And then in the rest of the course, we're going to cover the changes made in 2011 and 2014. There was another standard in 2017, but there are still one or two important features which are not supported by all compilers. We're going to cover changes to the core C++ language and the standard library, and important new features such as lambda expressions, move semantics and multithreading will have their own separate sections. The structure of the course is a series of videos. They'll consist of PowerPoint presentations like this one, so you can look things up easily, and there'll also be a demonstration of the topic in the IDE, so you can actually see the code compiling. Each video will have downloadable resources, which will include the source code from the video, some simple exercises just to check whether you've absorbed the material from the video, and solutions for the exercises. At the end of each section there'll be a workshop which is a bit more challenging. You may be asked more difficult questions, or you may be expected to combine different topics, sometimes from earlier parts of the course. And of course there will be solutions for these as well. I will be supporting the course very actively. If you have any questions about the course material, or you encounter any difficulties while you're taking the course, please use the Q&A facilities provided by Udemy, or you can send me a message through the messaging system. I will provide prompt and helpful replies to all questions, so I hope you enjoy taking the course and it meets your expectations and helps you with your career aspirations. At the end of each video, I say, I'll see you next time, but meanwhile, keep coding. And the reason I say that is that the best way to improve your skills and knowledge is to keep practicing. So make up little programs, take the examples and vary things, see what happens if you change them, see if you can work out why they behave differently, and so on. Okay, so that's it for this video. I'll see you next time, but meanwhile, keep coding.